As I was saying, there are fluffy lessons and there are hard lessons. And I tried not to just make this complete kindergarten level stuff. The intro to magnetism, we're keeping light for the most part. I did include some details. We're going to need this later on. Magnetism comes back. Once we've got more on electricity and static electricity, magnetism comes back and we're going to put them together. I want to preload you with some of the magnetism stuff. It fits in naturally at this point in the lesson. Preload you with some of the magnetism stuff so that when we get to electricity and magnetism, it doesn't break you. So, what we're going to do is pretty kind of fluffy. There are a couple of things that you can't just like nod your head and glaze over your eyes. You do have to actually think about. But there are only a few skills in here. There are only a few things to know in skills. I mean, I'm only giving 2 lectures on it, right? This will be on midterm. You do need to know it. But I weight the midterm questions proportionally to the number of lectures that we've had on it. So what? 3 weeks on electricity, 1 week on, 4 weeks on electricity, 1 week on magnetism. Electricity is heavily weighted. Yeah? Okay, so without just telling you that, I'm going to tell you stuff. Let's go into this. Magnetism. One of the very first things to know about magnetism, if not the first thing to know, is that magnetism is not electricity. What? Oh. And electricity is not magnetism. If I have an electron just sitting somewhere, it's not attracted to a magnet. If I have a piece of static electricity somewhere, it's not going to attract a magnet to it. Electricity and magnetism are super related, and in fact, in advanced, no, I'm not going to go there. Electricity and magnetism are super related, but you do need to know, very first thing, this probably is a test question, they are not the same thing. I'm going to introduce the idea of a magnetic field because writing down the force equation directly is god-awful. You don't want to go there. We're going to start here. What's a field? A field is an imaginary construct we use to separate out cause and effect. Look, A pushes B. You could do this with electricity as well. We'll talk about electric field after midterm. A pushes B. The idea of the field is we separate this out into A makes a field and then B feels the field. We separate out the push from the being pushed, in a sort. What actually happens? What do we observe? What's real? In my view, what is real is what we can directly measure and sense. So I would argue, to some extent, the field is an imaginary thing that we imagine around a magnet, around an electromagnet. Field lines are exuded, are created, are emitted, are sent out. And then, as we'll see, that can exert forces on things that are actually felt, create voltages, induce currents. So what is a field? It is the cause of a magnetic reaction separated out from the effect. First, we calculate how much something creates a magnetic field. Then we create how much that magnetic field pushes on something. So, that's the idea behind it. What is it? A magnetic field shows the direction, points in the direction that a compass would say is north. Which direction is the magnetic field anywhere on the surface of the Earth? North. Right? The Earth is a big honkin' magnet. Big honkin' electromagnet. If I take a bar magnet and bring it near a compass, I observe that north changes. Has everyone had a chance in their life at some point to mess around with a compass and a magnet? Hey, let me ask, who has never had the opportunity to screw with a compass and a magnet? Okay, you have homework. Are you in the lab section? Are you guys, you're on the lab section? The lab instructors have magnets and compasses in the supply cabinet. I want each and every one of you to spend 10 minutes after class, after lab someday, messing around with it. I could give you instructions on what to do, but like seriously, the biggest thing is I want you to have the experience of feeling magnets push and pull and seeing that magnets can affect the direction of a compass. That's all that you need to do. Everyone else, remember having done that, having had the experience of seeing north shift. Which way the planet is facing isn't really shifting. It's just that there's an overcoming, a stronger magnetic field nearby, right? As with electricity, opposites attract. Unlike electricity, we don't call those opposites plus and minus. We call those opposites north and south. Now, think about this. Don't look at the third point just yet for a second. Think about this. Meditate. Close your eyes. On the Earth, the direction that a north pole of a magnet is pulled is towards Antarctica. No, the Arctic Circle, right? And north attracts south, south attracts north, right? Poles. Let me ask you this. Is there a north magnetic side to the Arctic Circle? Or is the north pole of Earth the north magnetic pole in Antarctica? Google for me! If opposites attract and the magnetic field of ever on Earth points north, what polarity is the North Pole? Is Santa a South Pole magnetically, or is Santa a North Pole magnetically? Google question A. Again, Google question A, opposites attract. The north side of a compass magnet, compasses are magnets, if you didn't know that. The north side of a compass magnet points towards the Arctic Circle, and the south side points towards Antarctica. I ask you, what magnetic polarity is there where Santa lives? At the North Pole, geographically. Oh my sweet baby Jesus. Okay, plus and minus is not a valid answer. What I just said a second ago is we do not call magnetic field stuff poles pluses and minuses. That's electricity. Don't get them confused. The correct answer is either plus or minus. Oh, for God's sake, south or north. Ugh. Ugh. Okay, this never happens. The vast majority of you have correctly deduced that if the north side of a magnet is attracted, which way? That away, right? The north side of a magnet is attracted that away, and opposites attract, then if I go far enough that away, I'll find the south magnetic pole of the Earth. Right? Most of you got this. If you didn't get that, think about it for a second, and or memorize it if you've got to. Up in Alaska, or north of Alaska, in that Arctic Sea, somewhere up there, I don't know where, I'm not great at geography. The geographic north pole of the Earth has a magnetic south pole. And in Antarctica, there is a magnetic north pole. The north side of the Earth's magnetic field. I do want to emphasize, by the way, I mean, like, everyone who's played around with a magnet can observe pretty quick, or those of you who haven't are about to observe pretty quick, that you can overcome the Earth's magnetic field real easily. A bar magnet from the cheap bar magnet store can easily overcome a compass, can make a compass say north is that way instead of its true direction. So the Earth's field strength is actually very weak, 50 micro Tesla, 50 millionths of a Tesla. 5 times 10 to the minus 5 Tesla. Do you guys remember that you're supposed to know micro yet by now? Yeah? I won't answer this on tests. I won't tell you. You have to learn a couple of prefixes. Okay, good. 50 micro, 50 millionths of the base unit. You can make Tesla-sized fields without too much effort. I myself have built an electromagnet that generates 1/10 of a Tesla. It's big, but it's like, it's what, $100 of materials and a tenth of a Tesla, I have overcome the Earth's magnetic field by a factor of 10,000, right? Okay, so my point is, the Earth's magnetic field is not that big. Why do we even care about it? How do we notice it? Spread out over an enormous volume of space, there is tremendous amount of energy in the Earth's magnetic field. It is a very important thing, but the absolute strength anywhere around you is relatively diluted. So this is a number you need to know, 50 micro Tesla. This is a number that I will ask you to be able to estimate. You need to know that it is small, about this size. If you're doing a homework problem and it gives you the 52 micro Tesla, I will admit to you that is the more precise value. Use the value given to you. This is as close as I'm going to ask you to know, to be able to estimate. Google question B. Which direction, either north pointing with the magnetic field or north pointing against the magnetic field, does the compass line up? Again, does the compass needle point with the magnetic field, opposite the magnetic field, or I suppose you could say at right angles to the magnetic field? Okay, again, the question is, which direction does the compass point say is north? The same direction as the magnetic field, the opposite direction, right angles, 30 degrees away from? I seem to have produced some confusion. There is a distinction between points 1 and 3 here. They are different points. I define the direction of the magnetic field vector as which way does a magnetic compass point? Which way does a compass say is north? That's my definition of field. So which way does a compass line up? Read the definition, with. Okay, now let's think about the planet. Note that the planet is not the same thing as what I just asked. The planet as a whole has on top of it, there's a south side. On bottom of it, there's a north side. And that's why north compass needles are pointing towards Alaska and south compass needles are pointing towards Antarctica. Opposites attract. If a north compass needle points towards Alaska, there must be a south in Alaska. That has nothing to do with the first point. Okay, so which way does a compass needle point? Which way does it say north? The same direction as the magnetic field. What's in Alaska or the Arctic Sea? A south magnetic pole, not a minus pole, by the way. Okay. Now, compasses are good. Compasses are great. Let's pretend we know. Oh, and you can measure the strength of a magnetic field by just measuring how hard the compass wants to turn to face it. That calculation, explicit calculation, is god-awful. I'm not having you find that. I'm just going to give you a number. Magnetic field B equals so many Tesla. Now, let's go into the force that if I tell you magnetic field is 5 Tesla pointing this way, you need to be able to find how much force that exerts on something. There are 3 letters to find the force. What's Q represent in everything we've done so far? Energy is not correct. Charge. Charge is Q. Coulombs, that's an old pun. What does V represent? Little v, by the way. Velocity, speed, well, I always use big V for voltage, right? What does B represent? B is the magnetic field. It would be nice if it were M. That's a different quantity. I think it's called magnetic flux. I don't remember. So B times Q times V, very complicated formula here. If I multiply charge velocity, and magnetic field. That tells you how strong the magnetic force is on a charge. Note a couple of things. Note a couple of things. This is properly true. We're going to talk about directions now. If you are moving east-west, you get a force. If a charged particle moves north and south, magnetism of Earth does nada. If you move in the direction of the compass needle, if you move in the direction of the magnetic field, or exact opposite direction, no force. Here's a test question. Merry Christmas. If you can regurgitate this, you'll get a point. I think. I haven't written it yet. Very likely to be. If you move in the direction of a field line, the force on you is 0. This is the magnitude of the force if you were moving at right angles to the field line. What if you're not moving at right angles and you're not moving parallel? Then you need trigonometry, which will kill people. And I do not wish to murder you guys, not most of the time. So I have cut out everything referring to sine and cosine that I possibly could from this class. You do not need to know that the true formula is QVB sine theta. Oh! Pre-med students can care about that. Pre-med students, I've given you multiple resources, including the MCAT sessions. We could do that if you wish. Okay. So, if you move in the direction that a compass needle points north, in the direction of the field, or opposite that, your total force is 0. If you move at right angles to the magnetic field B, if velocity and field are crossed, you get to use QVB. And if you're at some other angle than 0 or 90, then it's not part of my class. I will only ever give you with, opposite, or right angles. So far, so good? It's kind of weird that magnetic direction, which way a compass needle points, is different than the direction that a charged particle points. Charged particle feels forced. That's weird, right? Hey, what's force if V is 0? I mean, plug in. What if you plug in 0 to V? 0. 0 force. This is another thing to reflect on. A charged particle just sitting there in a magnetic field, if you plug in speed equals 0, the force is 0. That's what I said a minute ago at the beginning of these slides. An electron just sitting there is not attracted by, nor does it attract a bar magnet. You have to move. Once you move, then the charge can feel magnetic forces. So, also, if Q is 0, does a neutron ever feel magnetic forces? No. Turn to your neighbor and talk about this formula for like 2 seconds, okay? This should be real simple. In experience, people sometimes miss some of the things. Turn to your neighbor and discuss real fast. Okay, I hear no productive teaching, learning going on right now. Ask me a question. Where are you struggling? What is hard here? Please. Field line is a line that we can draw on a piece of paper that shows which way the field points. Which way does a compass point north at that location? If you're on a field line, if a charged particle is moving along a field line, for instance, in the Earth's field north or south, then there is no force no matter how fast. I will tell you that. Or I might ask you, how could you get 0 magnetic force? Q is 0, V is 0, B is 0, angle straight. Yeah. Right. Good question. Others, ask me more. Please.
is 0, it means force is 0.
I mean, multiply 0 by anything, what do you get? No sorries. Okay? Multiplying three numbers shouldn't break you. The reason I think that many people struggled in the past is the direction is weird. The direction is, oh my God, I sound like a BuzzFeed headline. The direction will shock you. This is what requires your attention. In my experience, I suspect why people die at this next slide is because, or why people forget this is because what is to come drives it out of their brain. No, just multiply. Remember that you've got to be at right angles. Look at the numbers. Now let's talk directionality. Whoopsie. Here we go. This is the best picture I could find. The direction of the magnetic force is not the same way as a compass points, and it's not the same way as a charged particle moves. It's at right angle to both of those. And to find the direction at right angles, you use your right hand. Lefties have a small advantage in this because they could be writing their test while they're calculating. Wait, can be writing on their test while they're calculating. Everybody else, remember to put your pencil down. If you're writing with your pencil and calculating with your hand, deducing with your hand, you're gonna die. Never use your left hand. Put it in your pocket. Cut it off. I don't know. Jesus said something about that. If your left hand causes you to miss magnetic force problems. Yeah, something like that in the Bible? Yeah. Oh, if it causes you to sin. Well, I say missing these problems is a sin. Okay, let's do it. Let's do it. Let's do it. Here we go. Once this clicks, you'll never miss it. But it's got to click. Hold your hand out straight, thumb fully extended. Right hand fully extended, yeah? Don't change angles of your fingers at this point. Your first finger points which way the particle is going. Your index finger points which way is the particle going. If the particle is going to the left in this room, point your hand so that your fingers are going to the left. Go ahead, everyone do this. Now don't relax your thumb. Which way is your thumb pointing? Your thumb, next in this, there are more than one way to do this. The next vector, the next direction that you look at is which way is the field pointing. Let's say north is that way. I forget which way it actually is. If north is towards you, orient your hand so that your hand is backwards, towards the back of the room. No, that would be towards the right of the room. That's towards the back of the room. Hold them up high so I can see them. That's towards your neighbor. That's not towards the back. That's towards the back of the room. Hold your thumb up. That's towards the left of the room. You're pointing at me. Don't point at me. Continue to point left. There you go. That's it. Do you see your palm is facing you? Yeah, your palm is facing the back of the room. Let me scan. I'd like to check everyone. Oh, keep holding it up. This doesn't have to be hard. I swear. Everyone I see is doing it right. Your thumb points in the direction a particle would feel pushed. Pushed. Okay? So if you move to the left in a field pointing that way, you get pushed up. Yeah? Okay, now let's do a couple of problems involving this. No, really? Okay. Notation, right. There are two coordinate systems we need to use. I'll introduce them one at a time. One is the paper coordinate system, okay? To do this, you imagine that you're holding a piece of paper or a book up in front of you. Oh my God, like a projector screen, okay? I'm going to describe some directions, and they're really hard to remember, okay? This way is up. Duh, right? This way is left. Again, duh, yeah? Down, right? If you are holding a piece of paper or a book up in front of you, up, down, left, right are just up, down, left, right. The last one screws with people. The last axis screws with people. Am I pointing into the piece of paper or out of the piece of paper? I'm pointing out of, right? This direction points out of the piece of paper. If I imagined that I am shooting an arrow through this, I guess I'd have to stand behind, and the arrow is coming towards you. Is it going into the paper? No, it's coming out of the paper. Yeah? Now which direction am I pointing? Am I pointing into the sheet of paper or out of? Into, right? I define in the into, out to, up, down, left, right coordinate system, which is what we'll use the most of the time. I will define this as hold a book up in front of you, and the directions are, I mean, the bleedingly obvious directions. Up, down, left, right, out of the page, into the page. If I draw you a vector with a direction, if I draw you a little arrow with a direction on a piece of paper, you can trust me that that's the direction that I'm pointing. If the little arrow goes to the right, I'm talking about the right direction. I'm not talking about up. Which way does the arrow go? That's the way I'm talking about. Again, this confuses some people. It doesn't have to. This is more common sense. This is not a trick. Notation. Put the slides in the wrong order. Up, down, left, right, in, and out are relative to a piece of paper you're holding up in front of you. Here is the right direction. Just draw it on a piece of paper. Here is the up direction. Here is the left direction. Duh, yeah? Here's the down direction. Now I've got a problem. Oh, I have so many problems. I've got a problem. How do I draw something pointing out at you? How do I draw the out direction? I do not want to have perspective drawings because I suck at actual sketching, right? I want a convention that I can write down on the piece of paper without being an artist. Here is the convention for out. Here is the convention for in. Dot and X. I like to draw little circles around them. Makes it draw attention to them, but you'll see this in the homework. How do you remember that dot is out and X is in? Well, I imagine an arrow. What's the front of an arrow look like? A point, a dot, right? That's kind of the point of an arrow, pun not intended in that case. What would happen if I shot an arrow out at you through this screen? What would you see? A point. Just like the out symbol is the point. Imagine an arrow being shot at you. Oh my God, I'm going to die. You're seeing the point in your last moments. What happens if you shoot an arrow into the page? Don't actually do this. What happens if you shoot an arrow into the page? What's closest to your face? The feathers, also called the fletching. Yeah? You see the little X of feathers on the back? That's the X symbol. Imagine an arrow sticking into the board, sticking into the book, whatever. So these are the in and out directions. The other coordinate system I'll use is if you've got a compass and they're looking around, you can orient yourself. Oh, let's pretend. I don't actually remember. Let's say this way is north. Which way is this way? If that's north, which way is this way? This is not south. If this is north, east, never eat shredded waffles. Soggy waffles, sorry. Yeah? North, south, north, east, southwest if you go around clockwise? Huh? Wheat? W-E. No, or shredded wheat, yeah. Okay. Okay, so, if you don't know that, draw little compass rose on your paper. Starting from up on the paper, draw around northeast, southwest, clockwise. I will expect you know that, okay? I will also expect you know your left from your right. My wife has a real hard trouble with this because she can never intuitively remember. It takes a second for her. No judgment if you do struggle with this. Judgment if you don't account for it, if you don't learn from it. Okay, so if I've got northeast, southwest with a compass looking around the room, if this is north, that's east, if that direction is west, that direction is south, how would I define the other axis, the up-down axis? How could I describe this direction? Oh, I just said it. It's the up-down direction. If I'm talking about north, east, south, west, my third axis is the up-down direction. And that I will say verbally. I will not draw on the piece of paper. If I'm drawing on the piece of paper, I'll I'll draw little arrows to indicate. Arrows are the in-out symbol to indicate. If you see references to up-down, if you see directions that are north, east, south, west, the last direction is like common sense. Think about it, up-down. Please note, up and down depend on the coordinates you're using because this direction is up and so is this direction. On a piece of paper, there's an upward direction. You're holding it in your face. And in free space, just actually walk around northeast, southwest. Up is a direction. If I say up on a test, and other things are referring to north, south, east, west, and you answer in terms of left and right, you're going to lose the point. Northeast and south and west go together. Left, right, up, down go together. Left, right, in, out go together. Both have up, down. Don't just look at one word and guess the direction, okay? Turn to each other real fast and review. What directions are what? And what are the symbols? Ready, set, go.
Yeah, that's pointing up. This is like left down, right, wherever you want.
And it's up to down.
The palm is towards.
But then he said,
So
well,
that's
it's not. But he said left and right
That's
go
like what? We're going this way. That's just it.
No, up and down go together, but like up and down is for everything. There's always an up-down direction.
Zero. This is.
Uh-huh.
But left, right, up, down go together.
Uh-huh. Well, left, right, in, out
You know.
are together. If I'm talking about left and up, north isn't a valid answer. North isn't a geographic direction. And everything has up, down. If I accidentally give you something that talks about X, Y, Z, by the way, that's a third coordinate system, shoot me an email, it gets taken off. I have goofed before. X, Y, Z is a third coordinate system, and I'm not, let's do two things at a time, okay? Max. If you see X, Y, Z, I'll kill it. Okay, so you okay with up, down, left, right, in, out? East, west, north, south? Again, no judgment if you struggle with directionality. You're not the only one. My wife does. I won't judge you, but I will judge you if you don't take steps to learn it. I'll save this on top. Okay, there is a symbol in mathematics that refers to use the right-hand rule to find which way we go. And that symbol is the times multiplication with the x times, not the dot times. So if I write for you north times with the x west, there is a direction answer to this. What is north times west? No. North times west, use the palm of your hand. I don't know which direction north is. Again, let's assume that way is north, everyone. Put the front of your hand, fingers of your hand pointing north of your right hand. Okay? Make sure that the palm of your hand is facing which way is west? If that's north, which way would a compass say west is? Make sure the palm is pointing backwards. Oh, this is the same example as we just did. Which direction is north cross west? Up. Up. Yeah? Mm-hmm. North cross west is up. Take your hand. This is the right hand rule. If that's north, I don't remember. It doesn't actually matter as long as you can imagine some direction is north and know which way east and west are relative to that. First finger this way, first finger the north way. The palm of your hand is oriented towards the west direction, right? This is pointing west, yeah. I mean, the palm points out. Huh? That's the third finger. Third finger is the resultant. No. In this example, we'll do 5 more, 10 more. Who's getting confused by palm? Which way the palm points? Yeah, it is. It is. It is a little awkward sometimes. No one's confused by which way your palm points? Because there is an alternate using 1, 2, 3. If you can remember that this is 3. No? Okay, so if you could see which way your palm points. Please note, for this, again, very importantly, you got to keep your fingers rigid. I see people all the time ending up going like this. That's not the right hand roll. Fingers out. Fingers out. Okay. So let's do some more practice. How about what's east cross up? Here's how to do it. Again, I'm going to assume that that way is north. Which way is east? Yeah, now keep your fingers that direction because that's your finger direction. Take your fingers out. Which way is up? Duh, right? Turn your arm so that your palm is facing up. No, your palm is not facing up. Receive a Christmas present from your aunt. There, now your palm is facing up. Yeah? Please note, your fingers can't have changed direction in this. If your fingers were pointed towards the board, if your fingers were pointing towards which direction we think east is, you can't then be rotating your hand all over the place when you're finding which direction up is. So your fingers check. Are my fingers still pointing which way I'm imagining east is? Great. Which finger have we left? Which finger is left? Thumb. No, up is your palm. Your thumb is the result. Which way is your thumb pointing? South. Yeah? So east crossed up is south. Another one. Left cross up. On the piece of paper in front of you. Hold which finger or fingers to the left? Right hand. Use your right hand. I swear to do my right hand rule right. Hold your fingers left. Which way is up? Oh my God, palm up again. Right? No. If I'm talking about left, no, west does not make sense. Left and up are not north, south, east, west directions. Yeah? North, south, east, west go together. I see no north, south, east, west. I'm talking about in, out, up, down, left, right. Okay, so which way is my thumb pointing? No, not west. East, west is not a correct answer. In. Into the page. Your thumb is the arrow. Question. Sure, we can do that. It doesn't matter as long as you're consistent. Imagine any direction to be north. Imagine any direction to be north. I'm not going to ask you a test question saying, is it towards the instructor's side of the room or is it towards the back of the room, and expect you to know what that is. But if you imagine any direction to be north and the answer comes out east, you're going to get it right if you say east. No. 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 East is always the same direction relative to north, no matter which way north actually is. Question. How is your thumb pointed south if your palm is up? Well, I think if I hold my hand so that my palm is up, my hand is horizontal, right? My hand is horizontal. I can turn my body any direction. I can turn my arm in any direction while still keeping my palm horizontal and facing up, yeah? I can end up with my thumb pointing any direction. We're not looking at the piece of paper. We're imagining that somewhere around us is north and figuring out which way does my thumb point relative to that. If I imagine east is this way, then the resultant, my thumb is pointing that way relative to east, which is also called south. People who are doing this online, I'm sorry, but there's a reason that I say doing it in class is better. You may find YouTube videos are helpful at this point. Actually, this is true for all y'all. Lots of examples could be very helpful. What's left cross up? In. Yeah? Let's do some more. Let's be flexible. Say that way's north now. Okay, say that way's north. Imagine that way's north. What's up cross east? Google question C. Figure out which way up cross east is. Imagine this way's north. For the hell of it. Doesn't matter. Figure out which way up cross east is. Hold your hands in the air. What's up cross east?
So the palm, okay, the north, south, west, east, that way. Palm is up, right? So then palm is.
Your palm is not the first one. First one is your fingers. Right now your fingers are pointing east. Your fingers are pointing east. Up is the first. Up is the fingers.
Oh, up.
Mm-hmm. No, you just rotated which way your fingers are. You went like this. Your fingers are changing direction when you go like this. First you pointed with your fingers up, then you pointed with your fingers east. Don't do that. Keep your fingers up. Rotate your hand so that your palm points east. Yeah? You can't change the orientation of your fingers. Now, which way is that? Exactly. Up cross east is north. Let's see how many people is clicking. Google question C. Oh, come on. No? Oh, it just didn't load. Okay. Well, there's still lots of wrongos. It's like we need practice or something. But there's still lots of norths. I'll take it. Okay. Pick a direction. Any direction. Well, pick a direction. Any direction. East cross down. East cross down. Do east cross down. Google form D. East cross down. Google form D. Figure out which way east cross down is. Stick your thumb out. Which way is your thumb pointing? Exactly. Good.
Yeah, yeah, like.
I don't care, you know, wait, it's almost the same.
Okay, about the same number of wrongs. So on average, nobody learned. Let's try this together. Okay. Turn to your neighbor, help them out. If you're getting this wrong, ask your neighbor to watch your fingers and make sure they do not change which direction they point as you turn your hand. Okay? When you turn your hand, your fingers can't be going different ways. You're not pointing in this way, that way, the other way. I mean, you start pointing this way, that way, the other way, but then you don't also point at the other direction. East, which way is east? Let's imagine it is that way. Okay? Doesn't matter. East. Which way is down? Are we going to point this way? No. We're going to place our palm down. Which way is north? Which way is the resultant? North is this way. Yerp. Correct answer was north. Hey, I want you to notice a pattern. If I ask you an east or a west in this, is the answer ever west or east? Is the answer ever the same direction along the same axis as either the inputs? Let me ask you another question. If you hold your hand out like this, does your thumb ever point the same direction your palm's going? Do your fingers ever point to the direction your thumb is going if you hold your hand like this? No. So I'm going to put test questions on asking you to calculate this cross that. And I will put answers on saying up cross east is up. You can immediately roll that out. If you got up and down, east and west as two of the axes, the answer must be north or south. Another pattern to look for. If I flip my hand, first I was pointing east crossed up, then pointing east crossed down, flipping your hand over once, what does that do to the result? It's the relationship between north and south. It flips. If I have east crossed down versus east crossed up, down and up are opposite directions, right? I'm rotating my hand. Okay, which direction does your thumb go if you rotate your hand? It's flipped, right? If you flip one of the vectors in a cross product, that's what this is called, you are flipping the resultant. So if you just do it right once, you don't have to think about it again. You could just say, oh, I flipped one, the answer is the opposite is that. Hold your hand up, cross right, real fast. Up, cross right. Up, cross right. Yeah. Up, fingers, right. Not that way, that's towards. That's a way. That's way's right. Palm this way. Yeah. Push on the wall. Huh? Your thumb points which way? Nope. Nope. In. Tell me this. Real fast. Up cross right is in. Now calculate for me right cross up. What do your fingers do? Right cross up. Thumb is the direction that the index used to be. Index is the direction that the palm used to be, yeah? In turned into out. Convenient trick too. If I flip the directions, the answer flips. Up and east, south and north. If you flip the order, the answer flips. Left cross up cross left. Opposite directions. One last thing. Take your hand. I want you to keep your hand rigid. Point your fingers up and your thumb up at the same time. Keeping your hand rigid. Oh, you can't point two things at right angles in the same direction, yeah? Okay, put your thumb up and your palm down while keeping them rigid. You can't do that. You can't have things at right angles point in anti-parallel directions, right? It's impossible. If they're at right angles, they can't point in the same or opposite directions. So what if I ask you up, cross up, left, cross right? The answer is 0. That magnetic field exerts no force on that charge. So, for instance, half a second. For instance, what if the velocity of a particle is north and the magnetic field direction is north? What direction is north cross north? North cross north? 0. That's why magnetic field exerts no force on a northward particle or southward. Question?
Yeah. Will you quite literally give us questions like this?
Yes.
Like exactly.
Yes. Call it cross, by the way. But yes. Might as well use the same right terminology. Other questions? Turn to your neighbor, make up 3 examples and challenge them to it. Doesn't matter. Make up anything you want. North, south, east, west, up, down, left, right. In, out. Help each other out. Ready, set, go. You do 3, they do 3. I'm going to give you several minutes to do this. People online, you can do this for yourself. Pick any 2 directions at all, and work it out. This is what I just said. Don't look at this. Practice. There's nothing better than practice to get this. Cross east. 0.
They're all like two of the same thing.
Exactly.
But like,
You can't have two things parallel and perpendicular. That's the point. It's impossible. You can't have parallel and perpendicular at the same time. The right-hand rule is all about perpendiculars. Saying east crossed east or east crossed west is talking about two things being parallel and perpendicular. It's logically, it's geometrically impossible. You tell me. Wait, left and south are different coordinate systems. I don't know. Depends on which way you're facing, which way left is. Think of a piece of paper. How would I describe various directions of dots on paper?
Down.
I mean, if it's not geography, north, south, east, west, then it's paper. North, south, east, west, up. I mean, duh, right? If you know which way is east and west. But on a piece of paper, people tend to forget in, out is in, out. But just how would you describe it? Yeah, take a pencil, take a pen. Who's gonna have trouble remembering index finger is 1, palm is 2? You're okay with 1, 2, 3? Question first. Yeah, do it. Show me. This way. This way. Yeah, that's it. Which way is your thumb pointing? No, your thumb is not up. Correct.
and it was down the palm. Oh, that makes sense.
Yeah, down is that way. Like, really? Yeah. No one thinks you're going to confuse this is the second direction, this is the first direction? You got a cute little analogy if you can't. First direction is fingers. Fingers first, palm second. And the thumb shows which way the result is. It's a really cute little thing, but I'm not going to give it to you if you're confident you can remember 1, 2, 3. The thumb is the result of crossing. There are going to be several different times that we cross. Since force is velocity cross field, yes, in this case, thumb is the third, thumb is the fourth, thumb is the after the equal sign. But there will be many times that we cross. Last chance for questions before I move on. Nobody? Really? Really? Can we ever have in cross out or in cross left? You tell me. What's in out? Point your hand so that your perpendicular thumb and palm are both along that axis. Don't do it. You'll break your hand. You'll break logic. It is impossible geometrically to be pointing perpendicular lines along a parallel. So no, in cross out is impossible. Now, what was your other question? You gave a second one, and that's entirely possible. In cross left. Yes, in cross left is totally possible. Everyone do it. Everyone do it. First fingers in to the page. You're holding the page up, not relative to you. In to the page. In. This way's in, not out. In. Cross, what they say, left? Now don't change your finger direction. Rotate your arm so that your palm points left. Don't break your arm. Your hand was not pointing left. That way's left. Yeah, and you're right. I mean left. I am used to flipping my directions when I face the students, and then now I'm turning around to be your side. So yes, in, cross left. What direction is your thumb going? On the paper. Up. Well, actually also in 3D space too. Up, cross left, up. In, cross left is up. Okay, go make up some examples for yourself today. This really isn't hard once you can remember 1, 2, 3. If you can remember that assignment and keep your hand rigid, it's really straightforward. And I guarantee this will easily be a point or two on the midterm. So guess and you're screwed. But if you go out and make some practice for yourself and learn it or do the homework, you're going to do great. That's another 10%, 5 to 10% of your grade. Okay, now, you guys remember the tricks? Flip one of the directions, the answer flips. Swap the directions, the answer flips. If your directions are parallel or opposite, parallel or anti-parallel, 0. Yeah? I talked through that, but I wanted to write it down as well. Yeah? No, keep those thumbs stand straight. Okay. What the hell? Get out of here. You guys are good. This is enough. Now go do some practice, darn it. Go do some practice. Make it up and ask yourselves. This is enough for today. I love you all.